statistics. I would like to mention, I'm not going to mention this forever, but this being our first day, I'm definitely pounding the point home. Whenever there's a question for you to complete, pause the videotape, do the question, and then get started on it. Okay? All right, so now let's start playing. Types of statistics. That's what this video was all about. There are two types of statistical procedures. One is called descriptive statistics, and the other inferential statistics. What do you think descriptive statistics are? Well, descriptive statistics are brief descriptive coefficients, numbers, that summarize a given data set, which can be either a representation of the entire or a sample of the population. Descriptive statistics are broken down into measures of central tendency and measures of variability. Spread. Central tendency tends to be grouped together. For example, tables and graphs used to organize data. Descriptive values such as the average score are used to summarize data. Don't let this intimidate you. This is not the purpose of this. You're not supposed to know this. We're introducing these concepts. All right, so descriptive statistics describe, and that makes sense. So if we just think of the root word, we'll understand. Descriptive statistics describe a general population as a whole. Now, inferential statistics, they're a little bit different. Inferential, coming from the word inference, means draw a conclusion from, is a statistical method that deduces from a small but, and here's a key word, representative sample, the characteristics of a bigger population. In other words, it allows the researcher to make assumptions about a wider group using a smaller portion of the group as a guideline. So when we did our little work before and we said, okay, we're going to pull out a sample, and then when we pull out that sample, we're going to see how did the people in the sample drive, how would the people in the sample vote, and then we're going to make the conclusion for the entire population. We are inferring, to infer means to draw a conclusion, we are inferring from the sample what is the most likely outcome for the population. So that's an inferential statistic, okay? That was what was going on in the movie. They were trying to infer based on past performance. Is polling for a presidential election, then concluding you know who is likely to win, a descriptive or inferential statistic? It's inferential. Think of what the root word inference means. It means to draw a conclusion from, okay? So what we're trying to do here is we're trying to look at the sample and based on the sample, conclude it for the entire country in the case of a presidential election. Okay? Think of the definition of the root words to describe. With descriptive statistics, what we do is we get some raw data and then we describe what that data looks like. For instance, this is a pie graph. We had mentioned charts before being good examples of descriptive statistics. In this case, when we look at favorite color, 24% white, 22% black, silver 19%, blue 16, red 10, and other is 9. And then there's some male and some females that they're looking at there as well. This is describing the data, so it's descriptive statistics. Now, where can statistics go wrong? There can be a difference between what a statistic suggests of the general population and what actually is. All you need to do is look at political polls. They are constantly wrong, okay? Many of these mistakes can be traced to what we call sampling error, and that means how we establish the sample. The sample is supposed to accurately reflect the population. If it does not, any conclusions can often be wrong. They are faulty. Let's just give you a quick example, and I'm sure we'll go through some more in a couple of seconds, but imagine if we look at the population, remember the big picture of the population, and we pull out the small little sample box, and we're going to do a presidential poll. And let's say in the population, it was about half Republicans and half Democrats. And then let's say we pulled out the sample, and almost everybody in the sample was a Republican. Do you think the conclusions of the sample group would be accurate for the population? No. That sample group has to represent the general population accurately. Here's a really good, let's go back to this diagram. It's a really good way to understand it. Let me go back to that again. I thought I wrote something on there. Apparently I didn't. If the population was everybody in the country who was going to vote, and then we pull out that sample, and when we pull out the sample, it should, now the country is more or less 50% Republican, 50% Democrat, about. So the sample should represent that. If it's 55% Democrat, then the sample should be 55% Democrat. What it should not be is if the population is, let's just say 55% Democrat, the sample should not be 80% Democrat. Otherwise, that's what we call sampling error, and it's going to be off. The discrepancy between a sample statistic and its population parameter, remember parameters refer to the entire population, PPSS, is called sampling error. And that's why when we pull out that sample, it has to be very representative of the actual population. Defining and measuring sampling error is a large part of inferential statistics. In other words, if we draw the wrong inference, where did we go wrong? We want to know about that, and we have to measure that in statistics. Okay, so let's talk about sampling error. Population of 1,000 college students, the population parameters. Now, keep in mind, this is the population parameters. Parameters always have to do with the entire population. It does not say population statistic. Statistics have to do with samples. So the population parameter, the average age is 21.3 years. That's for the entire population. The average IQ is 112.5, and the population is made up of 65% female and 35% male. And based on that population, they make up two samples. One sample has 5 people in it: Eric, Jessica, Laura, Karen, Brian. And for that sample statistic, remember statistics come from sample. Again, I want to repeat, PP in the big circle at the top, SS in the 2 rectangles at the bottom. Sample statistics. Average age 19.8, average IQ 104.6, and it's 60% female, 40% male. Sample number 2, Tom, Kristen, Sarah, Andrew, John. Sample statistic, average age 20.4, average IQ 114.2, 40% female, 60% male. Do either of those samples represent accurately the population, the parameters of the population? Not exactly, right? The age is a little closer in the second one, but the first one, it's off, sample number 1. The average IQ is very far off in sample number 1. It's fairly close in sample 2, but then the percent female and male are very different in each one of them. So the sampling error can likely be traced to the fact that the samples did not represent the population. Okay? Now, statistics and research. Generally speaking, this is how we go about doing things. Let's compare 2 teaching models. The population of first grade, and the population is all the kids in the school's first grade. Sample A is taught by method A. Sample B is taught by method B. And those are obviously the test scores for the students in each sample. Now, we can get descriptive statistics or we can get inferential statistics. Remember, descriptive statistics, they organize and simplify. They describe what's going on. So what they did there was a dot plot, or in this case, a box plot, if you ever heard of such a thing. And it just records the data, and it says what the average score is. 76 for sample A and 71 for sample B. Okay? So again, these are not all of the students in first grade. The ones that were pulled out for sample A give sample A's results, and those for sample B come out there. We are getting statistics for sample A and statistics for sample B. We get parameters for the entire population if we look at it. Step 3, inferential statistics, starting to interpret results. Well, the sample data shows a 5-point difference between the 2 teaching methods. However, there are 2 ways to interpret the results. Number 1, there is actually no difference between the 2 teaching methods, and the sample difference is due to chance. In other words, they're only a little bit off, and, sampling error, chance, can account for that. The other one is there really is a difference between the 2 methods. and the sample data accurately reflects this difference. The goal of inferential statistics is to help researchers decide which one is the right interpretation. Is the right interpretation that, hey, there really isn't much difference going on here, it's just sampling error? Or is there really a difference between method A and method B? This is the kind of thing that you should know well by the end of the class. Okay, concept questions. A researcher is interested in the texting habits of high school students in the United States. If the researcher measures the number of text messages each individual sends each day and calculates the average for the entire group of high school students, then the average number would be an example of a parameter, because each individual in the population of the school, every one of them. A researcher is interested in how watching a reality television show featuring fashion models influences the eating habits of 13-year-old girls. A group of 30 13-year-old girls is selected to participate in the study. The group of 30 13-year-old girls is an example of a... I actually put the wrong answer down here. It should be, I misread the question here. This should be a sample, okay? So correction, ding, 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 ding. Correction, I used the word sample afterwards. It's not a statistic yet. I had to get some information from it. I was a step ahead of myself here. This is just a sample. Remember, PPSS, population and parameters, samples and statistics. Another concept question. A researcher is interested in how watching a reality television show featuring fashion models influences the eating behavior of 13-year-old girls. The amount of food eaten in one day, now I was a step ahead before, now we're getting there, is measured for each girl, and the researcher computes the average score of the 30 13-year-old girls. This average score is an example of a statistic because it's based on the sample of 30 girls. This is where I was a step ahead before. I apologize for that. Next, the average verbal SAT score of the entire class of entering freshmen is 530. However, if you select a sample of 20 freshmen, keyword there, sample, and compute the average verbal SAT score, you probably will not get exactly 530. What statistical concept is used to explain the natural difference that exists between a sample mean and the corresponding population mean? Choices A, B, C, or D. Go ahead. It would be sampling error. Okay? Sampling error is the little bit of difference that you're going to get between the sample and the, between the sample and the population. The discrepancy between a sample statistic and its population parameter is called sampling error. All right, that's as far as we want to go right now.